Solving inventive problems can be approached from many angles, and blending scientific, psychological, and unconventional techniques can lead to breakthrough ideas. One effective scientific method is to use structured problem-solving frameworks like TRIZ, a theory of inventive problem solving developed by analyzing patterns in patents. TRIZ provides systematic guidelines to identify contradictions and propose innovative solutions. For example, if you're trying to design a more efficient engine, TRIZ might help you resolve the trade-off between speed and fuel efficiency by suggesting ways to eliminate that contradiction. How can a systematic method like TRIZ boost creativity? It uncovers hidden patterns in technology that direct you towards solutions that might not be obvious at first glance. On the psychological side, techniques such as cognitive reframing and adopting a growth mindset can make a significant difference. Believing that your abilities can improve with effort encourages you to explore new ideas without the fear of failure. Practices like meditation and mindfulness help clear your mind, reducing stress and opening the door to fresh perspectives. Imagine taking a short mindful break and then returning to a stubborn problem. Suddenly, subtle connections might emerge that you previously overlooked. How does mental clarity contribute to effective problem solving? A calm mind is better equipped to notice and connect disparate ideas. Unconventional techniques often involve stepping outside your usual environment to spark creativity. Lateral thinking, for instance, challenges you to question assumptions and deliberately explore unrelated ideas. Consider using a random word generator. The unexpected word bridge might inspire a novel idea for connecting disparate technologies. Other creative methods include hands-on experiments, sketching ideas, or engaging in improvisational role-playing to break down mental barriers. Could unexpected associations be the key to solving a difficult problem? By linking concepts that are usually kept apart, you may unlock entirely new solutions that would remain hidden with traditional approaches. Combining structured scientific methods like TRIZ, psychological practices such as mindfulness and a growth mindset, and unconventional strategies like lateral thinking forms a robust toolkit for tackling inventive challenges. Each approach offers a unique perspective. Systematic methods provide clear pathways, psychological techniques clear mental clutter, and unconventional strategies encourage thinking beyond established boundaries. Might the blend of these diverse techniques be the key to unlocking your next breakthrough? Experimenting with these methods can reveal the unique mix that sparks your creativity and drives innovative solutions. Brainstorming for creative idea generation involves a collaborative technique that encourages the free flow of ideas without immediate criticism, allowing a wide range of possibilities to emerge. This approach leverages both individual creativity and group dynamics to unlock solutions that might not surface through linear thinking. And it is grounded in psychological principles that reduce fear of judgment and promote risk-taking, ultimately leading to breakthrough innovations by building on diverse perspectives. For example, a group of students brainstorming solutions to reduce plastic waste might generate dozens of ideas, from recycling initiatives to biodegradable alternatives, before narrowing down the best approaches. It's like opening a treasure chest of ideas where every coin represents a potential solution, and you sift through them to find the most valuable ones. Lateral thinking techniques involve approaching problems from new, unconventional angles, bypassing traditional step-by-step logic, and encouraging the exploration of alternative pathways and creative connections between seemingly unrelated concepts. Supported by cognitive psychology research that shows breaking habitual thought patterns can lead to innovative solutions, these techniques help individuals think outside the box and challenge standard assumptions. For example, a student might use lateral thinking to solve a design challenge by reimagining the problem from the perspective of the end user, discovering a novel approach that no one had considered. It's like taking a different route on a familiar path. By deviating from the usual road, you may discover a shortcut or a scenic detour that leads to a surprising destination. Design thinking and prototyping is an iterative, human-centered approach that focuses on understanding user needs, brainstorming, prototyping, and testing ideas by combining creative intuition with systematic problem-solving to generate practical, innovative solutions. By prototyping, ideas are transformed into tangible models that can be evaluated and refined, emphasizing empathy and continuous feedback to ensure that the final solution truly addresses the problem. For example, a team working on a new educational tool might create a series of prototypes, test them with peers, and refine the design based on real-world feedback. It's like sculpting a clay model. You continuously shape and adjust your creation until it perfectly fits the envisioned form. Mind mapping for visual organization is a visual tool that organizes thoughts, ideas, and information around a central concept while highlighting relationships and hierarchies. It harnesses the brain's natural tendency to think in patterns and associations, making complex problems easier to understand by structuring information in a clear, non-linear manner that reveals connections which might be missed in traditional lists. For example, a student might create a mind map to explore various factors affecting climate change, visually linking causes, effects, and potential solutions. It's like drawing a family tree where every branch connects relatives. Each connection helps you see the bigger picture of how everything is related. Reverse engineering to understand existing solutions involves deconstructing an existing product or solution to understand its underlying components and mechanisms. This analytical approach allows one to learn from proven methods and apply similar principles to new problems by combining scientific inquiry with practical experimentation, providing insights into how a solution works and how it might be improved. For example, a student interested in renewable energy might take apart a small solar charger to learn how its components work together, then use that knowledge to design a more efficient version. It's like taking apart a clock to understand how its gears and springs interact, then using that understanding to build your own timepiece. Incubation and the power of reflection is the process of allowing the subconscious mind to work on a problem while taking a break from active focus, which can lead to sudden insights or aha moments upon returning. This technique relies on the psychological benefit of stepping away from a challenge to let the brain process information in a relaxed state, often resulting in creative breakthroughs, and underscores the importance of integrating deliberate downtime into problem solving. For example, after intense study sessions, a student might take a walk or engage in a relaxing activity only to later come back with a clear, innovative solution to a challenging math problem. It's like letting dough rest before baking. Giving it time to rise and develop flavor leads to a better final product. Overcoming cognitive biases and mental blocks is crucial for unlocking creative problem-solving abilities by recognizing and challenging cognitive biases and mental blocks that limit our ability to see alternative solutions. These biases trap us in habitual thought patterns, and techniques such as questioning assumptions and using divergent thinking exercises help break these mental barriers, enabling more flexible, inventive thinking. For example, a student might intentionally list all the reasons a solution could fail and then work to find ways to address each concern, opening up new possibilities that were previously overlooked. It's like clearing fog from a windshield. Removing the obscuring bias allows you to see the road ahead more clearly. Unconventional techniques, scamper and lateral probing, are creative methods that encourage the reimagination of existing ideas by prompting you to view a problem from multiple, non-traditional angles. Techniques like scamper, substitute, combine, adapt, modify, put to another use, eliminate, and reverse stimulate inventive thinking by challenging established norms and opening the door to innovative adaptations of standard solutions. For example, a student might use the scamper method to rethink a common household item, exploring how substituting a component could lead to a new, useful invention. It's like taking a familiar recipe and experimenting with different ingredients and cooking methods to create a completely new dish. Systems thinking and holistic problem solving is an approach that examines how individual parts interact within a whole by considering the broader context of a problem. This method encourages looking at challenges from a holistic perspective, where the interconnections between various elements are mapped and understood, integrating both analytical and creative methods to generate comprehensive solutions that address multiple facets of a challenge. For example, a student tackling a community project might map out the various social, economic, and environmental factors at play, identifying key areas where interventions could have the greatest impact. It's like understanding how all the pieces of a puzzle fit together. You see not just the individual parts, but the complete picture, allowing you to solve the problem more effectively.